Hello again, happy people of the Pre-Calc world. Coming to you again from my kitchen table. Last time we talked about simple limits, where all we had to do to solve the limits was to use substitution. Today, we are going to talk about limits with factoring. So we're going to have to do some work before we can actually just substitute, because today we are going to have denominators, and it could be a possibility that our denominator is 0. So just like last time, I'm going to go through the slides I would have gone through with you in class, do the examples together, and then that'll be the day. All right, so with this slide, we are going to do the example with the limit as x approaches 3 of x minus 3 over x squared minus 9 together. But notice that if I did plug in 3 right away, 3 squared is 9 and 9 minus 9 is 0. So we would get a denominator that would be 0. And as you all know, we cannot divide by 0 because that is physically impossible. Doesn't mean anything. You can't take something and divide it into 0 pieces. So since our denominator will be 0 here, we're going to have to use our skills at factoring to see if things will cancel out. And then we can plug in the number to see what our limit will go to. So what number our function is approaching as we get closer to that number. So let's do that example together. So we have the limit as x approaches 3 of x minus 3 over x squared minus 9. And as I stated before, if we threw a 3 in there, 3 squared is 9, and 9 minus 9 is 0. So that poses a problem because we would get a 0 as our denominator in a fraction. So what we are going to do is we are going to factor either the numerator or the denominator, whichever one. So we can't factor x minus 3, but we can factor x squared minus 9. What multiplies to get 9 and adds to get a 0 in the middle? Well, that is x minus 3 times x plus 3. What's nice about that is because we're multiplying an x minus 3 and an x plus 3, and we have an x minus 3 on top, the x minus 3's cancel out, and we're left with the limit as x approaches 3 of 1 over x plus 3, which now, if we plug in our value of 3, we get 1 over 3 plus 3, or 1/6. So the number that we are, when as x approaches 3, our function is approaching 1/6. All right, so the next slide just has the 3 examples that we are going to be doing. If you want to pause the video at this point and try these 3 examples on your own, I think that would be a great strategy for you to know if you are doing this right, because I will go through each of these examples as we go through. So you could do a mixture, you could do the first one with me and then pause and then try the other 2 on your own, or you can just follow along with me as I go. All right. So that first example was the limit as x approaches 0 of x squared minus 3x over x cubed minus 4x. And the first thing you should always do is check to see if you plug in that number, what your denominator would be, because if it's not 0, you can just continue to plug in that number. So if I plug in a 0, I'll get 0 minus 0, which does get me 0 on the bottom. So we have to do some factoring, but we have x squared minus 3x with nothing afterwards. So we have to remember that we can also pull out a greatest common factor to factor. So on the top, we can pull out x. So we have the limit as x approaches 0. And on top, we can pull out an x. And if we do that, that leaves an x minus 3 when we divide both those terms by an x. And on the bottom, we have an x cubed and a 4x, and we can pull out an x as well. So we'll have x over x squared minus 4. All right, so if we do that, our x's cancel out, leaving us with x minus 3 over x squared minus 4. And now if we plug in zeros, we're left with a 0 minus 3 over a 0 squared minus 4. So we'll get negative 3 on top and 0 minus 4 on the bottom. So we get negative 3 over negative 4, which is a positive 3/4 as our answer. So hopefully you can see where factoring comes in handy, because we can easily take care of that problem of getting a 0 on the bottom if we can cancel some stuff out. All right, let's try that second example, which was the limit of, as x approaches 8, of x squared minus 5x minus 24 over x minus 8. So again, check the bottom, check your denominator to make sure that if you plug in that number, you get 0 or you don't. So if I plug in 8, I get 8 minus 8, which is 0. So that means I do have to do some factoring. I can't just plug in my 8 and get a value from there. So limit of x goes to 8. All right, so in this case, my numerator is x squared minus 5x minus 24. To factor that trinomial, we just have to ask ourselves what multiplies to get negative 24 and adds to get negative 5. And what multiplies to get negative 24 and adds to get negative 5 is if we had x minus 8 times x plus 3. That's over x minus 8. And like we had in the first example, now that we have an x minus 8 times something and an x minus 8 on the bottom, and they cancel out, leaving me with just an x plus 3. So to find the limit as x goes to 8 of x plus 3, I just plug in my 8, and 8 plus 3 is 11. So the answer to this limit is 11. So as x approaches 8, our function goes to 11. All right, I have one more example for you. This is the limit as x approaches 1 of x to the 4th minus 1 over x squared minus 1. If I put a 1 in, 1 squared is 1, 1 minus 1 is 0. So we do have to factor. Remember, if you don't get a 0 on the bottom, you can just plug that value in to all your x's and just find your value from there without factoring. So save yourself some work and some time and just plug the number in. But in this case, we do get a 0 on the bottom, so we are going to have to factor. So in this case, oh, my handwriting is getting worse as we go, sorry. We can factor the top and we can factor the bottom because they're both difference of squares again. So what multiplies to get negative 1 and to get 0 in the middle would be 1 and negative 1. So on top, because I have an x to the 4th, I can actually factor it into x squared plus 1 times x squared minus 1. And because I could do that, I could factor the bottom into x plus 1 times x minus 1. But if I keep it as x squared minus 1, the canceling out is going to happen again. As you can see, we have an x squared minus 1 times something on top, and x squared minus 1 on the bottom. So they cancel out. So I'm left with the limit as x approaches 1 of x squared plus 1. And if I plug in my 1 for my x, I'll get 1 squared plus 1, which is 1 plus 1, which is 2. So our limit simplifies down to the value of 2. So those are some examples of having to factor in order to simplify a limit. I hope you are all healthy. I hope you are all safe. And I hope you all have a great day. And I hope you all remember to do your homework, take a picture, and share it with me on Google Docs. All right. Bye, guys.